Hi everyone, welcome to Java Techie. If you are working with a microservices, you have probably heard about aggregator design pattern. It's a game changer when it comes to reducing network calls and improving latency. So in this tutorial, we'll deep dive into the aggregator design pattern. First, we'll look at the challenges of not using this pattern and then we'll see how it solved them. Finally, we'll do a hands-on example by building a simple microservices for an order tracking system. Okay? Alright. So without any further delay, let's get started. So to understand the importance of aggregator design pattern, let me walk you through one real-time example. Imagine you are order something online and want to track it. Well, here is the application I have built without an aggregator. Let's try accessing it. Then we'll understand the problem without aggregator design pattern. Okay. So let's say I will give some ID. Now before that, let me inspect it. Now send the request. This is your order ID and you want to track the progress of your order. So here is the result. We got order details, order ID, what is the item name, what is the status, order date. Again we got the shipping details and payment details. But it is working like a charm. What's the problem here? Let's break it down step by step. The first problem, your UI logic is getting complex as our frontend needs to call multiple microservices like order, payment and shipment. That means your frontend has to know all their APIs, contract and response structure. For example, if you will see here, our first API call to order service, this is what the URL, this is what the response, and this is the shipment service API, this is what the URL and this is what the response, and this is for payment. Now your front end needs to know all the structure of the request and response model, which is kind of a complex add-on on the front end code, isn't it? Now next, if you observe from the UI, we are calling three different microservices. First we call the order, then we call the shipment, then we call the payment. Again, we are doing this call on sequential manner, or you can consider as a blocking call. Meaning if the order service complete its execution, then it will make the next call to the payment, which will definitely increase the network load and latency, which could add a direct impact on your application performance. Currently in this example we are taking 3 microservice call, but what if we have 10 or 15 microservice call to just populate few data in your front end? Then in that case, doing 10 or 15 blocking call will definitely slow down your system, right? That you can consider as a big challenge if you are not using aggregator design pattern. Next, data enrichment overhead. Here if you observe, each microservice might return long or complex JSON response, but you only need few fields to just populate them on your front end. Now what your front end needs to do, he need to filter, merge and transform all the data before showing it. Now if you observe here, in this order service, we are returning only 4 field, right? What if I am returning 100 field, but I just want to only display 3 or 4 field in the UI? Then in that case, consolidate the response and display in the UI everything, all the task you need to design in your front end only, which is kind of extra work for your front end code, isn't it? And there are more chance to get more bug since you are doing everything on your front end. Hope this makes sense. Now next, complexity on error handling. How will you handle if any service goes down? For example, let me stop one of the service, shipping service. Now if I'll do the track order again, I'll give some different ID. Now if I'll do the track order, entire system or entire page is breaking down here. Can you see here? The order service, you got the response, this one. This is the status code 200, okay, but the shipping service is failed here, and your payment service giving status code 200. So this is not a good practice, right? If one of your service fail, then we must handle the failure gracefully rather than breaking the entire page. That's not acceptable at all, right? Next, security and exposure risk. Again, if you observe, different microservice might have different security mechanism. For example, let's say this order service implemented JWT, this guy use OpenID, and this guy might use some different auth or some different security mechanism. Now, to deal with all different kind of security, everything you need to write in your front end code. Apart from that, we are directly exposing all the services which could increase the attack surface. So dealing with all these type of problem are challenging in microservices world, isn't it? So to overcome these real world problems, aggregator design pattern comes into the picture. So if you see the flow, we have three different microservices, and we have a front end who is invoking all the three microservices directly. Now what you will do in aggregator design pattern will just add another middle layer to fill the gap between frontend and microservice direct communication. So instead, UI directly call the individual microservices. Let aggregator do that for you, and you will just simply call your aggregator service, which will helps to decouple your frontend with microservices direct call, isn't it? Now let's understand how this aggregator solve the problem we have discussed. Okay. Now the first problem we understand UI complexity, which is simplified if you are using aggregator service, because your front end is not directly talking to each and every microservices, rather it is just connecting to aggregator service without knowing the details about what is order service, endpoint, host, everything. Okay, without knowing the details about any microservices, your front end will call the aggregator service, and your aggregator will call to different microservices. Next, you can also improve the performance of your application. Rather than call each and every microservice sequentially, you can ask aggregator to call them parallel, so that you can reduce the latency and network load, and your performance will be boost if you are using this pattern for this kind of use case. Apart from that, your data enrichment process will be much easier in aggregator pattern. So whatever the response this order service, shipping or payment is giving to aggregator, that doesn't matter. What you want as part of the front end, let's say you want only 5 or 10 field out of these three service call. I am here as a aggregator service. I will consolidate the response what you want. Okay, I will transform and merge each and every response what you want. You just tell me what field you need. So all the responsibility will be taken care by aggregator service. So the data enrichment will be dead easy in aggregator. Okay. Apart from that, the aggregator pattern will give you the better resilience. When I'm saying better resilience, if any service goes down, then aggregator can implement fallback mechanism. For example, let's say shipping service is down, right? Rather than breaking down the entire page, I could give some cached information as a fallback response. So in this way, you can make your system better resilience. Next to that, you can also improve the security as part of your aggregator implementation, because the front end only interact with the aggregator, not internal microservices. So it will avoid complete security risk. We are not exposing multiple endpoints to outside of the world. So these are the benefits you'll get if you are using aggregator design pattern. And this is really an important design pattern in microservices world. Okay. So let's do one thing. Let's try to replicate same use case in action. So already I have created these three microservices: order, shipping and payment. So if I'll show you the code, there are no rocket science. I have just exposed one single endpoint on each microservices. Okay. So this is what something get shipping details. And if you observe here, I'm just hard coded few response. Similarly, if you'll go and check the order service, This is having a single endpoint who is returning some hard code response. And then we have payment. In payment also, I'm just returning some hard code value. Okay, so in each and every microservices I have just defined one single endpoint with hard code value. Now our task is to use the aggregator design pattern to simplify our job. Okay, so go to the Spring Initializer. We'll create our first project of this aggregator. We are using latest version of Spring Boot, that is 3.4.4, and then I will just fill all the required information. We'll only add web dependency. That is enough at this moment because we don't have any complex logic, we don't have any database integration or security kind of stuff. So we are good to go with only web dependency. Generate the project and import it to your IntelliJ IDEA. So this is our aggregator service who will communicate to these three microservices. Okay, so let's see what each microservice currently return the response. Go to order service. Order service is returning order object. Payment service is returning the payment object, and shipment service is returning the shipment object. So first, let's configure this response class in our aggregator service. Let's go to aggregator service. I'll create a separate package. Then just add these three classes: order, payment, and shipping. Next, if you understand the flow, from aggregator, we are going to call these three microservices through the REST API call. Again, it is up to you. You can use the web client to make it parallel execution, or you can use the completable feature. For now, I am going with the REST template. So using REST template, I will call these three microservices from aggregator. So for that, I will create three different client in my aggregator service. So let's create order client, payment client, and shipment client. So let's start with the order client. Let me annotate this at the red component. Then I need REST template, inject it, then define a method who will return with the order object. You can define fetch order, pass the order ID. Then since you have the REST template, it is dead easy to consume any REST API, right? You can define REST template dot get for object, because this is the HTTP method get. If you observe here in the order service, we have the get endpoint. Okay, so for that reason, I'm using get for object. Now, what is the URL? HTTP localhost. Then on which port your order service is up and running. If you go and check your order service resource application.properties, it is running on port 8081. Similarly, shipping service is running on port 8082. Payment is running on 8083. So just configure the same thing in our aggregator class. Then what is the endpoint to access your order? /order. Then pass the order ID, which is nothing your input. Okay. Now what it will return? It will return of data of type order dot class. Now you will get the order object as a response. Then you can return this particular order object. Better let's add few log statement so that it will easy to track whether the flow is going on or not. Private logger. Now here there could be a chance of network failure, right? You could also keep them in a try catch. Better let's do that. You can return. Now you just add a log statement here before and after your REST call, saying that logger dot info fetching order details for order ID. Then what order you have received, you can also add that log statement. What is the response you have received, you can add that. Just change the method. Again in catch also you can add a log saying that there is a error. What is the message? You can print that. Now let's follow the same pattern for all the client we have. Let me copy this. We'll only change the statement and parameter. Payment client, annotate at the rate component, paste it. It will return you the payment object. So you can change the log statement, fetching payment details for this particular order ID, and you can do the REST call get for object localhost payment service is up and running on port 8083, I guess. Yes, just change the port. Then what is the endpoint for this particular order ID, and it will give you payment as a response. We are good here, right? Now similar way do same for shipping client. Annotate at the rate component, paste everything, then change the logo statement. So change here, fetching shipping details for order ID is this. What object it will return you? It will return you the shipping object. Now just change the URL get for object localhost. It is running on port 8082. URL must be shipping, but let's verify it once again. Then it will return you the shipping.class. Change the object type. All good here, right? We have created three different client in aggregator. Now let's call these client and get the response, then transform the response the way you want it to return to your front end. So for that what I can do, I will create a controller class. You can create a service. From the service call all the client. If it is giving 100 field JSON response, 1000 field JSON response, create a DTO and map the field you need in the service class. Since this is the simple example, I am doing everything in the controller class. Annotate at the rate REST controller. Define the root URL or base URL. It is optional, but it's good to define the base URL. Aggregator. Then here I need to inject all the client, order client, payment client and shipping client, because the endpoint which I will expose, only my front end will access that. For that reason, from that endpoint I need to execute my logic to call different microservice and get the response back. Okay, so I'll just define endpoint here, public, keep it void for now. I'll talk about the return type. We'll pass the order ID, annotate get mapping and define the URL. I'll only pass the order ID in path variable, annotate here at the rate path variable. This is the basic annotations, right? So we are good at this moment. Now first let me inject all the three client what we have created. Now let's call each client from this endpoint. I'll call first order client dot fetch order, pass the order ID. What it will return to you? It will return you the order object which DTO already we created. Similarly, shipping client dot fetch shipping details, pass the order ID. Now call what is the next payment client dot fetch payment, pass the order ID. Anyway, the order ID what we are returning now, giving as a parameter, will get the same value as a response because you don't have any actual logic in any of our microservices. Okay, this is just a demo to understand the aggregator design pattern. drawback of not using it, then its benefit. So just return the payment, all good. We are getting these three response: order, shipping, payment by invoking three different microservices in aggregator. Now it is up to you how you want to build your response. For this endpoint, what you are exposing to your front end, what field from the order, what field from the shipping, what field from the payment you want to consolidate or merge as a response. That transformation logic you need to write based on your requirement. For now, I want to return all the field what I am getting, because we are only having three or four field in each microservice response, right? So for that, to consolidate all the response, I will create another class in DTO. Let's go to the DTO. I'll just create order details, then define all the field. You can customize the DTO. I mean, that is the common behavior, right? You can do that so that you can make your request response generic, or you can design the way you want as per your business. Okay, define constructor, toString, everything. I could go for Lombok, but it seems there are some issue with the latest Spring Boot version, so I'm not able to use it properly. I'll figure out and I'll update if there is any conflict with the latest version. Now I'll just return the order details. Pass order. Okay, you will get the response. Now, how you want to do the data enrichment part, you need to take care of it. Okay, and also, if you observe, this particular aggregator now taking the responsibility to call each and every microservices. He only kept all the structure of the request, response, and what is the host, port, everything, all the information we have only in the aggregator. Apart from that, we are not exposing all the endpoint directly to the front end, because it is abstract to the aggregator. Okay. Now, for example, let's say the order service implemented JWT and shipment service implemented some Octa. Then that header will take care by this aggregator. Okay. So that security stuff will also managed by aggregator. These are the benefits we have discussed, right? So we are good at this moment. Let's define the port 9090. Apart from that, since we are trying to access this endpoint, I mean this aggregator service from front end, we need to add the cross, we just need to enable the cross origin. So for that, I have a configuration. Let me copy this from order service and I will paste it. So if you observe, in each and every microservices, I just defined to allow all type of method, and if URL is coming with this particular origin, then allow that request. Otherwise, you will get cross origin error. Okay, so this is what the default configuration. We already aware about this. Just ignore it. Apart from that, since I am using the REST template, let me create a bean of REST template. So we are good with the backend code. Now let me start this server. We have started the aggregator service. Meanwhile, let's see the page, this order tracking. Okay, how we are trying to access. I mean, without aggregator, how from the front end we are invoking three different microservices directly. So let me show you the HTML code for it. I have used JavaScript and HTML code to demonstrate this example without including React or Angular. Now if you see here, I have defined a JavaScript method. Let me scroll down. Yeah, can you see here? From the front end, I'm invoking three different microservices. First API call, second API call, third API call. After that, I'm getting all the response and preparing the response to display the order details. Okay, and also manually handling the generic error, not for individual service error. But in this aggregator, what you can do, for example, let's go to the payment client. If any API call fail, you can implement the resilience 4j fallback mechanism. Give some cast information or give some dummy messages rather than breaking down the page. You can do that in your backend code. So in the old approach without aggregator, we are just handling the generic error. Okay, this is what the main code in aggregator, I mean without aggregator. This is what we want to eliminate with our aggregator approach. Now let me show you the API we are accessing through the aggregator. This is another HTML page. Again, JavaScript and HTML, no rocket science here. Just added a few CSS and Bootstrap to get better look and feel on the page. Now the key things we need to understand: what is the API URL? We are using the single API. Okay, and then whatever the response you are giving, I am only mapping it to the page to display the order details. Okay, so order.status, order.date, whatever the field you are giving, we are only displaying that. Fine. Now what I can do, let me go to the browser. This is crying, right? Just ignore it. I am going to close it. Meanwhile, we'll try with the aggregator. Just inspect it to show you that it is not doing 3 microservice blocking call. I'll give some order ID 1 2 3 4 5. Click on the track. How many request count we have now? Only one. Then definitely it will reduce the latency, right? It will reduce the network load, and we got the response here. Whatever the field you are sending as part of your aggregator service response, we are able to map them in the front end code. So whatever the benefits we have discussed, we are already aligned to it. When I'm saying already aligned to it, we are doing only one single API call, which will reduce the network latency and network load. Apart from that, the data enrichment part will be done or take care by the aggregator itself. Okay, and we are not directly exposing multiple endpoint URL, which will lead the security risk. We are only exposing a single entry point, and this guy will connect to your different microservice and will give you the response back. Fallback we have not implemented, but you can go for the resilience 4j. You can implement it. Already I cover how can you add a fallback using resilience 4j. You can check that. It's just defining one method and adding Spring Cloud dependency with resilience 4j. And again, for to make it parallel execution in your controller, rather than invoking these 3 client sequential, you can use the completable feature, or instead of using the REST client, not REST client, REST template, you can use the web client, which will be asynchronous call, right? So you can try for that. So I feel this aggregator design pattern is really helpful in microservices world. You just give a try with different use case and let me know if you have any doubts or concern. That's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.